Right, so in a previous video, I was talking about a concept from Formula One technology by Peter Wright, a concept of theoretical power. So theoretical power basically is K1, which is the equilibrium constant, multiplied by the theoretical flow rate of O2, multiplied by the theoretical calorific value of fuel burnt. But the actual power is something quite different. It says right here in this book, in reality, the actual heat energy released by the combustion process depends on numerous factors, the most important of which are the compression ratio and the heat losses to the cooling system of the engine. The cooling system of the engine is necessary to prevent components from exceeding their natural limits, their material limits. These all add up to a loss of energy that is quantified as thermal efficiency, the ratio of actual heat released to the theoretical heat released. All heat engines are a form of pump in which air, with its fixed proportion of oxygen, is drawn in from the atmosphere, compressed by a certain ratio in one or more stages, heated by the combustion of fuel with the oxygen, and expanded again to atmosphere in one or more stages. The expansion of hot gases liberates more power than needed to compress the air, and the balance is available to do work. The theoretical amount of air, and hence oxygen, that can pass through the engine with each revolution can be calculated with the physical details of the pump. However, the actual amount will depend on the losses incurred as the air and combustion gases flow through it. The actual volume compared to the theoretical volume is quantified as the volumetric efficiency. Due to intake and exhaust resonance effects, this exceeds 1 or exceeds 100%. Not all the network available from the process is useful. Some is used in overcoming friction, pumping the air, and driving accessories necessary for the functioning of the engine, e.g. fuel pump, lubrication, cooling pumps, and generator. The actual work available to the theoretical work is the mechanical efficiency. The actual power generated is now K1 multiplied by the theoretical flow rate of O2 multiplied by the theoretical calorific value of fuel burnt multiplied by thermal efficiency multiplied by volumetric efficiency multiplied by mechanical efficiency. The theoretical flow rate of the oxygen, however, that can be divided into two things. So the theoretical flow rate of oxygen is a function of swept volume and RPM. So the equation now becomes actual power equals K1 divided by swept volume multiplied, K1 multiplied by swept volume multiplied by RPM multiplied by the theoretical calorific value of fuel burnt multiplied by thermal efficiency multiplied by volumetric efficiency multiplied by mechanical efficiency.